Hello and welcome to this course where I shall be discussing the AWS Identity and Access Management Service, commonly referred to as IAM or IAM. This is a key security service within AWS and is likely to be the first security service you will use and come across, allowing you to configure specific access controls within your environment. Before we start, I would like to introduce myself. My name is Stuart Scott. I am one of the trainers here at Cloud Academy and I specialise in AWS, Amazon Web Services. Feel free to connect with me with any questions using the details shown on screen. Alternatively, you can always get in touch with us here at Cloud Academy using the community forum where one of our cloud experts will reply to your question. This course has been designed for AWS administrators, security engineers, security architects, or anyone who is looking to increase their knowledge of the IAM service in preparation for an AWS certification. This course will cover all features and elements of IAM, which will include what is identity and access management. This lecture will explain what IAM means and why it's necessary to implement and maintain control of the service. Groups, users and roles. This lecture will define the differences between groups, users and roles and how each of these objects are typically used. IAM policies. This lecture will discuss what IAM policies are, how to create, modify and apply them within your AWS environment. Multi-factor authentication, MFA. This lecture will explain what MFA is and its best practices. Identity Federation. This lecture will look at how to access your AWS resources using identities outside of the IAM service. IAM features. This lecture will focus on the information contained with the IAM account settings, the credential report, and also how IAM integrates with KMS, the key management service. By the end of this course, you will be able to set up and configure users, groups and roles to control which identities have authorization to access specific resources. You'll be able to implement multi-factor authentication, create and implement IAM policies, allowing you to grant or restrict very granular and specific permissions across a range of resources, implement a password policy to align with your internal security controls, understand when and why you may use Identity Federation access, and you'll understand how the key management service KMS is used in conjunction with IAM. Although this course will explain everything from the ground up to do with IAM, having some basic hands-on experience of AWS and awareness of other services may help, but it's not essential. Feedback on our courses here at Cloud Academy are valuable to both us as trainers and any students looking to take the same course in the future. If you have any feedback, positive or negative, it would be greatly appreciated if you could use the comments section found on the landing page of this course. That brings us to the end of this lecture. Coming up next, we're going to look at what is identity and access management and what it actually means. Hello and welcome to this lecture, where I shall provide an overview of what the Identity and Access Management Service is and what IAM actually means. Firstly, I want to define what is meant by identity and access management. I shall break this down into two parts, starting with identity management. Identities such as AWS usernames are required to authenticate to your AWS account. Authentication is the process of presenting an identity, in this case a username, and providing verification of that identity, such as entering the correct password associated. The second part, access management, relates to authorization and access control. Authorization determines what an identity can access within your AWS account once it's been authenticated to it. An example of this authorization would be the identity's list of permissions to access specific AWS resources. Access control can be classed as a mechanism of accessing a secured resource. For example, username and password, multi-factor authentication, MFA, or federated access. MFA and federated access will all be explained in greater detail as we go through the rest of this course. So essentially, IAM can be defined by its ability to manage, control and govern authentication, authorization and access control mechanisms of identities to your resources within your AWS account. We do have an existing course dedicated to AWS authentication, authorization and access control mechanisms, which goes into great detail on each topic. This course can be found here. Having an understanding of the different security controls from an authentication and authorization perspective can help you design the correct level of security for your infrastructure. Now we know what IAM relates to, let me explain what the service actually does. As I just explained, The AWS IAM service is used to centrally manage and control security permissions for any identity requiring access to your AWS account and its resources. This is achieved by using different features within IAM consisting of users. These are objects within IAM identifying different users. Groups. These are objects that contain multiple users. Roles. These are objects that different identities can adopt to assume a new set of permissions. Policy permissions. These are JSON policies that define what resources can and can't be accessed. And access control mechanisms. These are mechanisms that govern how a resource is accessed. Each of these features will be discussed in detail as I take you through this course. Within AWS, some services are regional and some are global. IAM is a global service, meaning that you do not have to create different users or groups within each AWS region that you have resources. IAM covers all regions. IAM is the first service a user will interact with when using AWS. The reason being, the identity needs to be authenticated by IAM before accessing any AWS resource. This could be via the AWS Management Console within your browser, or via the AWS command line interface using an API call trying to gain access to a resource. It's critical to understand how IAM works and what can be achieved via the service, but it's even more important to know how to implement its features. Without IAM, there would be no way of maintaining security or control of who or what could access your resources and what they could do with them, both internally and externally. IAM provides the components to maintain this management of access, but it's only as strong and secure as you configure it. The responsibility of implementing secure, robust and tight security within your AWS account using IAM is yours, the owners of the AWS account. You must define how secure your access control procedures must be, how much you want to restrict users from accessing certain resources, how complex a password policy must be, and if users should be using multi-factor authentication. All of this and much more is down to you to architect and implement, and much of it will likely depend on your own security standards and policies within your information security management systems. From within the AWS Management Console, the IAM service can be found under the Security, Identity and Compliance category. And when accessed, it will take you to the IAM dashboard. From here, and if you have the correct permissions, you'll be able to administer all security from an IAM perspective. The initial dashboard of the IAM console will display information relating to the IAM user's sign-in link, and this is a URL link that you can send to users who will need to gain access to your AWS Management Console. This link can be customized by clicking on the Customize button to make it easier to remember and read. If you had multiple AWS accounts, this customization would help you distinguish between your accounts. IAM Resources. This section provides an overview of your IAM resources using a simple count of the number of users, groups, roles, customer managed policies, and identity providers you have configured within IAM. Security status. This is populated with 5 best practices from a security perspective that AWS IAM recommends you configure when using IAM, which may include activate MFA on your root account, create individual IAM users, use groups to assign permissions, apply an IAM password policy, and rotate your access keys. When you implement any of the listed best practices, the status of them will change from an orange warning sign to a green tick to show you have achieved and implemented a recommended best practice. I recommend you try to adopt these best practices at your earliest opportunity. Maintaining tight security is paramount when working with an IAM solution. That brings us to the end of this lecture, where we looked at what is meant by IAM, what the AWS IAM service is and does, where the service is located within the Management Console, and what information is held on the IAM dashboard within the Management Console. In the next lecture, I'm going to introduce you to users, groups and roles and the part they play within IAM. Hello and welcome to this lecture where I am going to define the user, group and role objects within AWS IAM and the differences between them. Following this, I'll provide a demonstration on how to set up and configure all 3. Let's start with users. Users are objects created to represent an identity. This could be a real person within your organization who requires access to operate and maintain your AWS environment. Or it could be an account to be used by an application that may require permissions to access your AWS resources programmatically. Users are simply objects representing an identity which are used in the authentication process to your AWS account. When creating a new user, You have the option to create it via the AWS Management Console or programmatically via the AWS CLI, tools for Windows PowerShell, or using the IAM HTTP API. For this and other lectures, I shall be using the AWS Management Console to demonstrate how to configure various elements of AWS IAM. User object creation involves the following 7 steps. Setting the user details by creating a username, which can be up to 64 characters in length. Next, you'll select the AWS access type, either AWS Management Console access or programmatic access. To use the AWS Management Console access, the user will need to be issued with a password. For programmatic access, an access key ID and secret access key ID will be issued to be used with the AWS CLI, SDKs, or other development tools. You'll then need to define a password if AWS Management Console access was requested. Then permission assignment through the use of policies attached to the user itself or inherited from a group that the user can be assigned to. And you'll then need to review and confirm the information. After this point, the creation of the user will take place. Then you can download the security credentials within a CSV file that will contain the username, keys required for programmatic access, and the console login link, etc. These details can also be emailed to the new user using the send email link. I just want to cover a point I mentioned in step 2, access keys, which are required for programmatic access for authentication. These access keys are comprised of 2 elements, an access key ID and a secret access key ID. The access key ID is made up of 20 random uppercase alphanumeric characters, such as the one on screen. The secret access key ID is made up of 40 random upper and lowercase alphanumeric and non-alphanumeric characters, such as the one displayed on the screen. During the creation of a user who requires programmatic access, you are prompted to download and save the details, as the secret access key ID will only be displayed once, and if you lose it, you will then have to delete the associated access key ID and recreate new keys for the user. It's not possible to retrieve lost access key IDs, as AWS does not retain copies. These access keys must then be applied and associated with the application that you are using that requires the relevant access. For example, if you are using the AWS CLI to access AWS resources, you would first have to instruct the AWS CLI to use these access keys to authenticate and provide authorization. The method of performing this association varies based on the application and system that you are using. However, once this association has taken place, it ensures that all API requests made to AWS are signed with this digital signature. Once your user identity is created, you can view a summary of the object by selecting the user from within the user page of the console. This will show the user ARN, which is the Amazon resource name, which is a unique identifier of the object, the creation time of the user object, any attached policies that are associated with the user, any group memberships that the user belongs to, the details of the security credentials of the user, which also allows you to manage the current password, which enables you to change the password of the user. You can also manage multi-factor authentication. Configuring MFA allows for an additional level of security to be applied, and this should be used for the AWS account owner and any other users who have administrative access as a minimum. You can manage any signing certificates, and signing certificates are used for secure access to certain AWS product interfaces. And you can create new access keys for programmatic access, and it's a good practice to rotate and change your access keys periodically. From here you can also upload SSH public keys for AWS Code Commit. These are used to authenticate access to AWS Code Commit repositories, and you can also generate HTTPS Git credentials for AWS Code Commit, and this allows you to authenticate HTTPS connections to AWS Code Commit repositories. Also on this screen, an access advisor shows a list of services that the user has permissions for and the last time that those services were used with those assigned permissions. This is great to help you refine and revise the user's permissions. For those unaware of what AWS Code Commit is, it's a managed source control service that allows you to host secure and scalable private Git repositories. For more information on AWS Code Commit, try our lab, which can be found here. You may notice that on point 4, when I mentioned permission assignments, that these can either be assigned to the user or inherited from being a member of a group. Now you may also remember from the previous lecture when I explained about the security status on the IAM dashboard screen that one of the best practices listed was use groups to assign permissions. With this in mind and as best practice, you should consider using groups for permission assignment over assigning permission to individual users. So let's now take a look at the groups to help explain why. IAM groups are objects much like user objects, however they are not used in any authentication process. However, they are used to authorize access to AWS resources through the use of AWS policies. IAM groups contain IAM users, and these groups will have IAM policies associated that will allow or explicitly deny access to AWS resources. These policies are either AWS managed policies that can be selected from within IAM, or customer managed policies that are created by you, the customer. More information on IAM policies will be discussed in a lecture devoted to this element. Groups are normally created that relate to a specific requirement or job role. Any users that are a member of that group inherit the permissions applied to the group. By applying permissions to the group instead of individual users, it makes it easy to modify permissions for multiple users at once. All you would need to do is modify the permissions of a group, and all users associated with the group would inherit the new access. The alternative would be to update permissions for each and every user, which is time intensive and prone to human error, which is why it's best practice to assign permissions to groups rather than individual users, especially in an enterprise environment. Creating a group is very simple and is essentially a three-step process. Firstly, you give your group a meaningful name. You will then assign permissions via policies, and finally, review your group. Once created, you can then assign users to the group. From a limitation perspective, your AWS account has a default maximum limit of 100 groups. To increase this, you'll need to contact AWS using the appropriate limit increase forms. Also, a user can only be associated to 10 groups, so do bear this in mind when assigning permissions. Now we have looked at users and groups, let me now explain what an IAM role is. IAM roles allow users and other AWS services and applications to adopt a set of temporary IAM permissions to access AWS resources. This could be required to enforce security best practices. Firstly, let's look at an example of how the Amazon EC2 service uses an IAM role. Consider the following scenario. You have an EC2 instance running an application that requires access to Amazon S3 to put and get objects using the relevant API calls. To allow access to S3, a set of credentials could be stored on the EC2 instance itself, allowing any application to use those credentials to gain access to the relevant bucket for any put or get API requests. However, in this scenario, you would need to manage these credentials manually, including the rotation of access keys, which is obviously an administrative burden. To alleviate this issue, the EC2 instance could be assigned an IAM role that would contain the relevant permissions granting the EC2 instance and its applications access to S3 to perform the put and get API calls. This assignment can be made during the EC2 instant creation by selecting the role to be associated, or once the EC2 instance is up and running, a role could also be applied. An existing role associated to an EC2 instance can also be replaced by a different role if required. From a security best practice perspective, you should always associate a role to an EC2 instance for accessing AWS resources over storing local credentials on the instance itself. There are many advantages to roles. The IAM roles themselves do not have any access keys or credentials associated to them. Instead, when used, these credentials are dynamically assigned by AWS. Also, imagine you have a fleet of EC2 instances all performing the same task and using the same role. Now consider that your existing application, which was used to perform put and get requests, was now only required to perform put requests only, and get requests must be denied. To make the change, all you would need to do is to alter the permissions assigned to the IAM role, and all EC2 instances associated with that role would now have the correct access. If this same scenario happened by embedding credentials locally on the EC2 instance, then again, this would take a long time to replicate the change on every instance. Let's now look at how IAM roles can be used with IAM users. There may be circumstances where you'll need to grant temporary access to AWS resources for a particular user. Instead of adopting their group permissions or granting permissions to the individual user, which as we know is not best practice, we could simply allow the user to assume a role, temporarily replacing their existing permissions. To do this, the user must first be given permission to adopt the role via an access policy. Let's take a deeper look at roles to see how they are constructed and the different types of roles that are available. There are currently 4 different types of roles that can be created, all of which serve a different purpose. Firstly, the AWS service role. This role would be used by other services that would assume the role to perform specific functions based on a set of permissions associated with it. Some examples of AWS service role would be Amazon EC2, AWS Directory Services, and AWS Lambda, etc. Once you have selected your service role, you would then need to attach a policy with the required permissions and set a role name to complete its creation. Secondly, the AWS Service Linked role. These are very specific roles that are associated to certain AWS services. They are predefined by AWS and the permissions can't be altered in any way, as they are set to perform a specific function. Examples of these AWS Service Linked roles are Amazon Lex Bots and Amazon Lex Channels. Once you have selected your Service Linked role, you simply need to assign it a name and complete the creation. Remember, these roles do not allow you to modify the permissions assigned. Thirdly, roles for cross-account access. This role type offers 2 options: providing access between AWS accounts that you own and providing access between an account that you own and a third-party AWS account. This access is managed by policies that establish trusting and trusted accounts that explicitly allow a trusted principal to access specific resources. Many services use roles to allow cross-account access to resources. At a high level, these roles are configured as follows. The trusting account is the account that has the resources that need to be accessed. The trusted account contains the users that need to access the resources in the trusting account. A role is created in the trusting account. A trust is then established with the role by entering the AWS account number of the trusted account. Permissions are then applied to the role via policies, and the group of users in the trusted account then need to have permissions to allow them to assume the role in the trusting account. These group of users would have a policy attached to the group, which would look something like the following, where the red text would be modified appropriately with the relevant information. Lastly, role for identity provider access. This role type offers 3 different options. Grant access to web identity providers. This is used to create a trust for users using Amazon Cognito, Amazon, Facebook, Google, or any other OpenID Connect provider. Grant web single sign-on to SAML providers. This allows access for users coming from a SAML provider, which stands for Security Assertion Markup Language. And grant API access to SAML providers. This is similar to the previous option, but it allows access via the AWS CLI, SDKs, or API calls. For these options, a trust relationship is set up between the external identity providers to allow access to your AWS account's resources using their existing identity provider login information. I shall be covering more on Identity Federation in greater depth in a lecture later in this course. Now we have covered users, groups, and roles, let me provide a demonstration showing how each of these are created. Within the demonstration, I shall perform the following steps. I will start by creating a group. I will then attach permissions to this group by using an existing AWS managed IAM policy. Then I shall create a new user. As a part of this process, I shall assign this user to the group as per best practice. I shall then set up a new service role to be associated to an EC2 instance, and I will then assign this role to an EC2 instance at creation. Okay, so I'm at the home screen of the AWS Management Console. If I just type in IAM as a service, that'll bring it up. Then it'll take us to the dashboard. Now from here to create our group, we'll need to go along to the left and select Groups. Click on Create New Group. Give this group a name, Cloud Academy course. Click on Next Step. And here we can attach a policy to this group. So this is where we attach a list of permissions that we want the group to have. Let's filter this list by typing in S3, and that'll just bring up all the policies that are S3 related. So if we select this AWS managed policy, you can tell this is AWS managed because it has the little AWS icon here, and any custom policies are just blank here. But later in the course, I'll explain the difference between AWS managed and custom managed. But for now, let's just select the Amazon S3 full access. And go down to next step. And that's pretty much it. So here we just need to review what the settings we've made. So we've given it a group name and we've given it a policy as well for permissions. And then click on create group. And that's our group created. Now, if you want to take a look at that, if we select it here, CA course, and then we can see we have 3 tabs: users, permissions, and access advisor. So the users tab, we can use this to add users to the group. At the minute, it doesn't have any users, and we can see up here, users in this group is 0. And if we want to look at the permissions, this is the policy that we applied, and we can have a look at this policy. And it's very simple. It simply allows all actions within S3 to any resource. But we'll cover more of the policies later in the course. And then access advisor, and this simply shows the service permissions granted to the group and when they were last accessed. So what we need to do now is add a user to the group. So let's create a new user, and for this we go over to users, add user. Let's give it a username, so we'll call it CA user1. And then down here we can select the access type, and we can have programmatic access, which will give the user an access key ID and secret access key, or we can just allow them to the AWS management console, which will give them a password to sign in, or they can in fact have both. For this example, I'm going to give them programmatic access and also management console access as well. So we can allow the console to auto-generate a password, or we can type in a custom password here. I'm going to leave it as auto-generated, and we can set this tick box here to ensure the user creates a new password the next time they sign in. So next, if we go to permissions, now from here we've got a few options. We can add this user to a group directly from here. We can copy permissions from another user, or we can attach an existing policy directly to the user. Now, attaching policies directly to a user is not best practice. It's always best to add users to a group and then attach policy to that group. So what we can do here, we can attach the user directly to a group. So as that's already selected, we have the options down here of the different groups. Now we created the CA course group, so we're going to attach them to that. And as we can see, that gives them S3 full access. Click on next to review. And now we can see the details that we've entered here. So we have the username of CA user1, the access type, which is programmatic and console access. The password is auto-generated, and it requires a password reset. And the permissions we have given them is via this group here, the CA course, which we created just a few minutes ago. Then if we create user, and that's it. The user has been created, and here we have the access key ID, and also the password as well. So we can send an email directly to the user that will give them their credentials. You can also show the access key and password here as well. So you can make a note of those if you need to. You can also download these credentials as a CSV file. So I'll show you what that looks like. The same credentials, the username, the password, and the access key, etc. And also a console link to allow them to sign in. So let's go back to the user. So that's created, we have the credentials, and let's click close. And now if we go back to our groups and click on our CA course group, we can see that this now has one user attached. So this user will inherit the permissions from this group. Okay, so what we've done is we've created a group. We assigned that group permissions using an AWS managed policy. We then created a user and added that user to the group. So that user now inherits the permissions that's applied to that group. Now, the last part of this demonstration, I just want to show you how to create a role, and we're going to create a role and assign it to an EC2 instance. So I've come across to the roles section here. Here's a list of existing roles. Click on new role. Now I want this to be an AWS service role. And here we have Amazon EC2, which allows EC2 instances to call AWS services on your behalf. So I'm going to select that role. I'm going to apply permissions. This time I'm going to look for RDS and allow RDS full access. click on next step. Give this role a name. Call this Cloud Academy RDS Full Access. There's a description that you can change there if you need to. I'm just going to leave that as default for this demonstration. We can see our policy here that we just added. Then click on Create Role. Okay, so now what I want to do is create an EC2 instance and associate that role with the instance. So let's go across to EC2. Just going to very quickly launch a new instance. So Linux AMI, T2 Nano, go across to configure. Just going to leave all that as default. And then down here, we can see we have an IAM role. Now, if we click on this drop-down list, we can see that we have two roles. This is the one that we just created just a moment ago. And then we can view and launch. And we can see here that in our summary, if we go to our instance details, we can see that we have the IAM role there as well. If we launch that instance, click on launch. If we go across to view, and again, we can see in the instance details down here that it has that role associated. So this EC2 instance has full access to RDS. So this EC2 instance can contact RDS and carry out any API calls relating to it. Now, what I just want to quickly show you as well, recently AWS allowed you to change the role once it was associated to an EC2 instance. Before this, the only way you could attach a role to an EC2 instance was on creation, but now you can change it once it's up and running. So let's go across to actions. I've got the instance selected here, actions, and if we go down to instance settings, and we can say attach/replace IAM role. And now again, we can select our role, and we have this other one here, S3 full access. Simply change it there, click on apply, and then you get a message to say operation succeeded. And we can now look down at the instance details, and we can change that the role permissions for this instance has changed. It now has S3 full access permissions, so which means this EC2 instance can perform any API call to S3. And that brings us to the end of this demonstration. Thank you. We have now come to the end of this lecture. Coming up next, I will be discussing IAM policies like the one we just attached to our group and role in the previous demonstration. Hello and welcome to this lecture, where we will be taking a deeper look at IAM policies and how these are created, modified and constructed. I will also show you the syntax and structure of these policies. So as we already know, IAM policies are used to assign permissions to users, groups and roles. But what do these policies look like? IAM policies are formatted as JSON documents, JavaScript object notation. And each policy will have at least one statement where the structure may look like this example. Let me break the structure of this policy down to allow you to understand each element. The version. This specifies the policy language version, and at the time of writing this course, the current policy version is 2012-1017. Statement. This defines the main element of the policy, which will also include other sub-elements, including SID, action, effect, resource, and condition. These elements will identify the level of access granted or denied and to which resource. So let's now understand what each of these are for. SID. The SID statement ID is simply a unique identifier within the statement array. As you add more permissions, you will have multiple SIDs within the statement. Action. This is the action that will either be allowed or denied depending on the value entered for the effect element. Actions are effectively API calls for different services. As a result, different actions are used for each service. For example, the delete bucket action is available for S3 but not EC2, and likewise the create key pair action is available for EC2 but not S3. The action is prefixed with the associated AWS service. For example, you can see on the screen here we have two actions for CloudTrail. One is to create trail and the other is to delete trail. Or you could, as seen on screen, Use an asterisk as a wildcard which represents all actions for the CloudTrail service, essentially granting full access to the service. Effect. This element can either be set to allow or deny, which will either grant or restrict access for the previous actions defined in the statement. These two options are explicit. By default, access to your resources are denied, and so therefore, if this is set to allow, it replaces the default deny. Similarly, if this was set to deny, it would override any previous allow. Resource. This element specifies the actual resource you wish the action and effect to be applied to. AWS uses unique identifiers known as ARNs, Amazon Resource Names, to specify specific resources. Typically, these ARNs follow a syntax of partition. This relates to the partition that the resource is found in. For standard AWS regions, this section would be AWS. Service. This reflects the specific AWS service, for example S3 or EC2. Region. This is the region where the resource is located. Some services do not need a region specified, so this can sometimes be left blank. Account ID. This is your AWS account ID without hyphens. Again, some services do not need this information and so it can be left blank. Resource. The value of this field will depend on the AWS service you are using. For example, if I were using the action S3 put object, then I could use the bucket name that I wanted those permissions to apply to using the following ARN. Condition. This is an optional element that allows you to control when the permissions will be effective based upon set criteria. The element itself is made up of a condition and a key value pair, and all elements of the condition must be met for the permissions to be effective. In the example, the IP address is the condition itself, which the key value pair will be effective against. The AWS source IP is the key, and the IP address is the value of the key. So effectively, what this is saying is, if the source IP address of the user who is using the policy is within the 10.10.0.0/16 network range, then allow the permissions to be used. As I mentioned previously, you can have multiple SIDs within a statement, each granting a different level of access. The example below demonstrates this, and I have highlighted each a different colour to show the separation. The first SID allows any resource full access to CloudTrail as long as their source IP address is within the 10.10.00/16 range. The second SID allows any resource to have full access to autoscaling. The third SID allows the creation and deletion of S3 buckets within the IAM course CA bucket on S3. Typically, an IAM policy will have these elements that we have just discussed, but sometimes additional elements are and can be used. A full listing of these elements can be found here. Now we know what an IAM policy looks like, I want to talk to you about two different types of IAM policies available, these being managed policies and inline policies. Managed policies come in two different flavours, AWS managed policies and customer managed policies. These managed IAM policies can be associated with a group, role or user, although assigning to a user is not best practice. The difference between AWS and customer managed is as you would expect. The AWS managed policies have been pre-configured by AWS and made available to you to help with some of the most common permissions that you may wish to assign. For example, these two AWS managed policies covering S3. By selecting one of these policies, the necessary IAM JSON policy and its permissions will already be configured. The two policies are configured as follows. The difference between the two, separating full access from read-only, is made clear in the action element. The great thing about these AWS managed policies is that you are able to edit them and make tweaks and changes before saving it as a new policy. This then becomes a customer managed policy. This is great when an AWS managed policy is almost as you need it, as it saves you time creating the policy from scratch. Let's look at a scenario. A user requires read-only access to everything on S3, plus the ability to create new buckets for management purposes. To create the appropriate policy for this user, we should consider using the AWS managed policy Amazon S3 read-only access, which would give us the read-only permission, but it would need to be copied and altered to allow the creation of buckets too. Therefore, during the creation of this policy, the AWS managed Amazon S3 read-only access policy would be selected and then edited as shown in red to grant the additional create bucket permissions. So customer managed policies are any IAM policies that do not follow a predefined AWS managed policy. There are a number of ways to create a customer managed policy, these being the following. Copy an AWS managed policy. This is what we just covered, where an existing AWS managed policy is used and then edited to create a new customer managed policy. The policy generator. This allows you to create a customer managed policy by selecting options from a series of drop-down boxes. And you can create your own policy. If you are proficient in JSON and the syntax of IAM policy writing, then you can create your own policies from scratch or paste in a JSON policy from another source. I now want to give you a quick demonstration of how to create a policy in each of these three ways. The demonstration will include how to create a customer managed policy by editing an existing AWS managed policy, how to create a customer managed policy using the policy generator, how to create a customer managed policy from scratch, and how to validate your policies and why this is important. Okay, so I'm at the AWS Managed Console, and if I just go across to IAM, and then across to Policies, and Create Policy, and here we have three options. Copy an AWS Managed Policy, the Policy Generator, or create your own policy. So I'm going to cover each option, but to start with, I'm going to copy an AWS Managed Policy and create a customer managed policy by doing so. So if we click on Select, we can see here a list of AWS Managed Policies. Now for my policy, I want to have a policy that allows S3 full access and also EC2 full access within the same policy. So if I search for S3, we can see here that we have an AWS managed policy that provides full access to all buckets via the AWS Management Console. So that's what I want, but I also want to add EC2 full access as well. So if I select that, and we can see here that this is the policy, the JSON policy. For these permissions, we can see the effect is allow, the action is S3, and the resources is all. So I want to edit this to also include EC2 full access. So I can copy that section there, paste that in, and change the action here to EC2. So now what we have are two elements within the statement, one that allows full access to S3 and another allows full access to EC2. Now to verify that I've entered this correctly, there's a validate policy button down here. Now it's always worth clicking on that when you're creating your policies because it will let you know if there's any errors within the policy document that you need to correct. So if I click on validate policy, we can see here that there's an error on line 8. It's expected comma instead of a bracket. So if we go down to line 8 and add our comma in, go down to validate policy again, we can see that the policy is now valid. So let's give this policy a name. So we've got S3, let's say, and EC2 full access. Click on create policy. And our policy has now been created. Now, if we go to filter here on policy type and select customer managed, we can see here that this has filtered all the customer managed policies that I have. And the latest one here is the Amazon S3 and EC2 full access. Now we can have a look at that. Now we can see that it allows two services, EC2 and S3 full access to all resources. And if we want to see the policy document, then we can just view it there. And we can also edit the policy again. So let's create that same policy, but via a different method. So if we go to create policy, let's this time use the policy generator. So click on select. And this uses a number of drop-down boxes to make it easier if you're not too familiar with JSON and editing policies, etc. So our effect is allow. We can select our service. So first of all, we want Amazon S3. Actions, we want full access, so that's all actions, but you can select different ones here if you just want to create or delete buckets, etc., or delete objects. But for this demonstration, we want full access. And the Amazon resource name, we want all resources, so just put in the asterisk. Click on Add Statement. Now we want to also allow EC2 as well. So let's find that, Amazon EC2, Actions, all resources, Add Statement. So here you can see the statements that we've added. So the effector is both allow, the action of S3 and EC2, and to all resources. If we go on to the next step, we can see that the policy has been created for us. It's laid out slightly differently, but the effect is still the same. So we can see we have the statement ID, the effect of allow, the action is S3 with all resources. And if we have a look down here, we have another statement ID with effect of allow and the action of EC2 and all resources. Click on validate policy. Policy is valid. If we give the policy a name, S3 and EC2 full access from the policy generator, create policy. And again, if we go down to our policy type, customer managed, we can see that we have our policy here, customer managed, and again, full access for EC2 and S3 to all resources. So let's create the policy for a third time, exactly the same, but this time creating your own policy. So this will simply open up a blank policy editor document. And here you can write your own policy as you need to, or paste it in from another document, which is exactly what I'm going to do. So all I need to do is paste it into this document here. And as you can see, I have the action of S3 for everything, effect, allow, resource, everything, and the same for EC2. Now, if I validate policy to make sure I've created it correctly, we can see that I need a policy name. So let's give this EC2 and S3 custom, validate policy, and we can see that the policy is valid. Go to create policy, and again, one final time, customer managed, and we can see EC2 and S3 custom. And again, we can see that services EC2 and S3 has full access to all resources. So that's the 3 different ways that you can create a customer managed policy. You can select whichever way is easier for you. If you're not too familiar with writing your own policies, then the policy generator is probably easiest. Or if you want to use the bulk of an existing AWS managed policy to create your own, then the top option is probably best. So each of those policies that we created were all the same. They all gave full access to EC2 and S3. There was just different ways to create them. That brings us to the end of this demonstration. Thank you. Now we have covered managed policies, I want to go back to inline policies. Whereas a managed policy could be attached to multiple users, groups, and roles, inline policies cannot. An inline policy is directly embedded into a specific user, group, or role, and as a result, it is not available to be used by multiple identities. To add an inline policy for within the AWS Management Console, you must select the user, group, or role, select the Permissions tab, and click on Click here to add an inline policy. You will then be given 2 options in creating your inline policy. 1, using the policy generator, or 2, writing your own custom policy. When the policy has been created, it's then associated to your IAM object. As a result, inline policies do not show up under the policies list within IAM, as they are not publicly available for other users, groups, or roles to use within your account like managed policies are. Inline policies are typically used when you don't want to run the risk of the permissions being used in the policy for any other identity. When the user, group, or role is deleted, the inline policy is also deleted, as this is the only place where the policy exists. With the ability to attach multiple managed and inline policies to an identity object in IAM, what happens when there are conflicting permissions assigned to the same user, for example? The rules for reviewing permissions is very simple and can be summarized as follows. By default, all access to a resource is denied. Access will only be allowed if an explicit allow has been specified within a policy associated with an identity. If a single deny exists within any policy associated to the same identity against the same resource, then that deny will override any previous allow that may exist for the same resource and action. An explicit deny will always take precedence over an explicit allow. That now brings us to the end of this lecture covering IAM policies. Coming up next, I'm going to give you an overview of multi-factor authentication, MFA. Hello and welcome to this lecture where I shall be discussing the access control method of MFA, multi-factor authentication. Typically, when a user logs into the AWS Management Console, they will authenticate to your AWS account by providing their identification, typically their username, and then verify this identification, usually with a password. These two elements, identification and verification, allow the user to authenticate. For many cases, the verification, the password, is sufficient enough to confirm the identity, the username. However, for users who have a high level of authorization, for example, these users may have full access to a large number of AWS services, then you may want to, or be required to, due to governance controls, implement an additional verification step within the authentication process. This adds another layer of security attached to the identity, and this is where multi-factor authentication comes in, MFA. The name explains itself. It's used to create an additional factor for authentication in addition to your existing methods, such as password, therefore creating a multi-factor level of authentication. So what is this additional level of security that MFA brings within AWS? Well, MFA uses a random 6-digit number that is only available for a very short period of time before the number changes again, which is generated by an MFA device. There is no additional charge for this level of authentication. However, you will need your own MFA device, which can be a physical token or a virtual device. AWS provides a summary of all supported devices found here. Personally, I use Google Authenticator on my phone because it's simple and easy to set up and configure. Before a user can authenticate with MFA, it must be configured and associated to the user. As we know, as a part of the authentication process, we need to ensure that the verification element confirms the identity of the user. This configuration and association can be done from within the IAM console, and I will now show you how quick and easy this is to do via a quick demonstration. Okay, so I've already logged into my AWS account, and the first thing I need to do is go to IAM, which is under Security, Identity and Compliance. So we need to go into IAM to select the user that we want to give multi-factor authentication to. So if we go over to the users, and I have a user here, CA user 1, Cloud Academy user 1. So if we select that user, if I go across to security credentials, we can see down here that the assigned MFA device is no. So we want to give this user an associated MFA. So if we click on the edit button there. Now I'm going to be using Google Authenticator on my phone as the MFA device. So that's a virtual MFA. So select that and click on next step. Now this is a quick splash screen just saying that if you do have a virtual MFA, you need to install a compatible application on either your phone or PC, etc., which I've already done. Like I said, I'll be using Google Authenticator, so we can just skip past that step. Now, as a part of the setup of the MFA with this associated user, we can scan that QR code using Google Authenticator, and that will give us 2 activation codes. The first one, which will go in this box here, and then after a few seconds, it will give us a second code that we enter here. So this is just to synchronize. So if I go ahead and do that. So the first number is giving me is 745559. Then in just a few seconds, that will present me a second number as a part of the synchronization process. And that's 443393. And then we simply click on Activate Virtual MFA. So that's given us a message saying that the MFA device was successfully associated. So if we finish that and try to log in as this user. So the username was CA user1. I'll put in the first authentication method, which is the username and password. And you'll see here that the MFA users need to enter their code on the next screen. So by clicking sign in, it should present us with another authentication screen. And here we are. So here we need to enter our MFA code. So if I go back into my Google Authenticator and take a look at the number issued by the user, 061695, and click on submit. And there we go. We're authenticated into the AWS Management Console, where I can then access any resources that I have permissions to. There are also times when you can use MFA to increase security when making API calls to other resources. For example, if you are creating a cross-account role between AWS accounts, then you have the option during the creation of the trust to enforce MFA authentication to assume the role. That brings us to the end of this very short lecture. Coming up next, I'm going to discuss Identity Federation. Hello and welcome to this lecture where I shall be discussing Identity Federation, explaining what it is and the different types of federation that is available and how to create identity providers within IAM. Identity Federation allows you to access and manage AWS resources even if you don't have a user account within IAM. Identity Federation allows users from identity providers, which are external to AWS, to access AWS resources securely without having to supply AWS user credentials from a valid IAM user account. An example of an identity provider can be your own corporate Microsoft Active Directory. Federated access would then allow the users within it to access AWS. Other forms of identity providers can be any OpenID Connect (OIDC) web provider. Common examples of these are Facebook, Google, and Amazon. If you want to understand more about OpenID Connect, please see the following link. As a result, if you need users to access AWS resources that already have identities that could be used as an identity provider, then you could allow access to your environment using these existing accounts instead of setting each of them up a new identity within AWS IAM. The benefits of this is twofold. It minimizes the amount of administration required within IAM, and it allows for a single sign-on solution. As the vast majority of organizations today are using Microsoft Active Directory, using MSAD is an effective way of granting access to your AWS resources without going through the additional burden of creating potentially hundreds of IAM user accounts. As a part of the configuration process to implement federated authentication, a trust relationship between the identity provider and your AWS account must be established. AWS supports two types of identity providers: OpenID Connect, also often referred to as Web Identity Federation, and SAML2. OpenID Connect allows authentication between AWS resources and any public OpenID Connect provider such as Facebook, Google, or Amazon. When it's set up and configured, an access request is made by a user to an AWS resource. The identity provider credentials will be used to exchange an authentication token for temporary authentication credentials. These temporary credentials with pre-configured permissions allow authorized access to the resource as required. For this example, the process could be managed more effectively with the use of Amazon Cognito, which helps manage user sign-in to mobile and web apps through federated access. For more information on Amazon Cognito, please see the links on the screen. SAML2 based federations can allow your existing Active Directory users to authenticate to your AWS resources, allowing for a single sign-on solution. SAML stands for Security Assertion Markup Language and allows for the exchange of security data, including authentication and authorization tokens, to take place between an identity provider and a service provider. In this case, the identity provider is a Microsoft Active Directory service and the service provider is AWS. Once configured, let's take a look at how this Active Directory authentication mechanism is established. This example will assume the user within an organization requires API access to S3, EC2, and RDS. This scenario will also include the use of an AWS service called Security Token Service, STS. The Security Token Service allows you to gain temporary security credentials for federated users via IAM associated with IAM roles and policies. More information on STS can be found here. Let's look at this in more detail via a diagram. A user within an internal organization initiates a request to authenticate against the Active Directory Federated Service, ADFS server, via a web browser using a single sign-on URL. If their authentication is successful by using their Active Directory credentials, SAML will then issue a successful authentication assertion back to the user's client requesting federated access. The SAML assertion is then sent to the AWS Security Token Service to assume a role within IAM using the Assume Role with SAML API. More information on this API can be used on the link on screen. STS then responds to the user requesting federated access with temporary security credentials with an assumed role and associated permissions, allowing S3, EC2 and RDS access as per our example. The user then has federated access to the necessary AWS services as per the role permissions. This is a very simple overview of how federation is instigated from the user for API access to specific AWS services. Corporate Identity Federation is always authenticated internally first by Active Directory before AWS. To use federation within IAM, you must first create an identity provider, which is a simple process providing you have the correct information from your chosen identity provider first. This required information is as follows. For OIDC providers, you will need a client ID, also known as an audience, which you will receive once you have registered your application with your identity provider. This ID is usually a unique identifier. You must also obtain a thumbprint to verify the certificate of your identity provider. SAML providers. You will need a SAML metadata document that you can get by using your identity management software from your identity provider. This will include information such as the issuer's name, expiration data, and security keys, which are used to validate the SAML authentication response from your identity provider. Further information on these requirements and how to get them is outside of the scope of this course. However, further information on these elements can be found within the IAM user guide with a link on screen. To create an identity provider for OIDC, the process is as follows. From within the IAM console, select Identity Providers. Next, click on Create Provider. Then select OpenID Connect. Enter the URL of the identity provider. Enter the client ID, known as the audience, of your application that will communicate with AWS discussed earlier. Supply the thumbprint for server certificate verification. Then create a role for the identity provider. Verify the information and click Create. And the OIDC provider will then be created. To create a SAML provider, the process is slightly different. From within the IAM console, select Identity Providers, click Create Provider, select SAML, enter a name for the identity provider, point to the SAML metadata document discussed earlier, and then verify the information and click Create. This now brings us to the end of this lecture on federation. Following this, I shall be looking at a few other features of IAM. Hello and welcome to this short lecture where I'm going to look at some of the other features of IAM. This will include an overview of the IAM account settings, along with an explanation of the credential report, and finally the integration of KMS within IAM. Let me start with the account settings. These can be found in the menu bar on the IAM console. The account settings contains information relating to your IAM password policy and security token service regions. The password policy is used and adopted by your IAM users that you have created. There are a number of different components that you can change within the password policy to align it to any security controls or standards that you may have to ensure you maintain compliancy. Let's say, for example, your security standards required the following from your password policy. A minimum of 10 characters in length, alphanumerics along with uppercase and lowercase letters. Users are allowed to manage their own password. The expiration of your password should be set to 30 days, and the same password must not be used from the previous 5 passwords used. If this was the case, then your password policy would be configured as shown. Once you have set your password policy, you must click on Apply Password Policy to activate it. The second element of your account settings are at the bottom of the screen, which relates to security token service regions. This is the list of regions that are either activated or deactivated for the security token service. By default, all regions are activated. However, you can deactivate some if required for increased security. To deactivate, simply click on Deactivate for the required region. Okay, so let me now talk about the credential report, what it is and what it looks like. This can be accessed by selecting Credential Report on the menu bar of IAM. From here, all you need to do is click on the Download Report. This will then generate and download a CSV file containing a list of all your IAM users and their credentials. It's worth noting that the credential report will only be generated once every 4 hours. For example, if you downloaded a credential report for the first time at 1 PM, a new report will be generated and downloaded. If you then wanted to download another credential report at 4 PM, a new report will not be generated. Instead, the existing report that was generated at 1 PM would simply be downloaded instead. To generate a new report, you have to wait at least 4 hours from the previous generation. The report itself is comprised of a number of columns, which are fairly self-explanatory. However, here is a brief rundown of what each column means. Feel free to pause the video and take a read. This credential report can be useful for when you're auditing your security services. You can use the information within the report to ascertain if specific standards are being met, such as access key rotation, or if additional levels of authentication are being used by implementing MFA. This report could also be sent to external auditors to help secure evidence of compliance. I now want to move on to the final part of this lecture, which looks at how the key management service is linked with IAM and what you can use it for. I won't go into deep detail of KMS as we have a separate course for that which can be found here. The Key Management Service is a managed service by AWS that enables you to easily manage encryption keys to secure your data. Through the creation of these keys, you are in control of how these can be used to encrypt your data. If you lose or delete your encryption keys, they cannot be recovered. It's up to you to administer the keys and administer how they are used. IAM allows you to create and manage your KMS Customer Master Keys, CMK, from within your IAM console. The CMK is primarily used to protect data keys, which are used to encrypt your data within AWS. To administer your CMK, select Encryption Keys within the side menu bar. From here, you're able to create a new CMK, view any existing CMKs, which will show which region the key exists in, the alias, the key ID, its current status, and the creation date of the CMK. From here, you can also go back and edit and tag your keys too for greater management. Like I mentioned previously, a full explanation of KMS and how to use it to encrypt your data can be found in the course dedicated to the service. This now brings us to the end of this lecture. Coming up next, I will briefly summarise what we have covered throughout this course. Hello and welcome to this final lecture where I just want to briefly summarise some of the points that we have looked at. You should now have an understanding and overview of what the Identity and Access Management Service is and does, and the different components of the service that allows you to effectively secure access of your identities to your AWS resources. We started off by looking and understanding what was meant by IAM and how this linked to authentication, authorization and access control, which are used heavily within the service. Next, we looked at the different components of the service, starting with users, groups and roles. Let me just quickly provide an overview of these three components again. I defined users as objects representing an identity which are used in the authentication process to your AWS account. User objects are created to represent an identity. This could be a real person within your organization who requires access to operate and maintain your AWS environment, or it could be an account to be used by an application that may require permissions to access your AWS resources programmatically. IAM groups are objects much like user accounts, however they are not used in any authentication process. They are used to authorize access to AWS resources through the use of AWS policies. The groups contain users, and these groups will have IAM policies associated that will allow or explicitly deny access to AWS resources. IAM roles allow users, other AWS services and applications to adopt a set of temporary IAM permissions to access AWS resources. This could be required to enforce security best practices. Following this section, I then explain more about IAM policies. I explain that IAM policies are formatted as JSON documents, and each policy will have at least one statement where the structure may look like the following example. A full explanation was given as to what each item defined within the policy to allow you to start creating your own custom policies. We also learnt that there are two types of policies, AWS managed and customer managed. AWS managed policies are predefined IAM policies that are already configured, allowing you to assign them as required. Customer managed policies are created and modified by the customer, so essentially any other policy outside of the AWS managed policies. After looking at policies, I explained what multi-factor authentication was and why it is used. For many cases, the verification of an identity requires more than just a password to confirm the identity. In these cases, typically those identities with a high level of authorization, these users should have MFA associated to their accounts as an additional verification step within the authentication process. This adds another layer of security attached to the identity. Using an MFA device, which can be a physical token or virtual device, a random 6-digit number is generated for a very short period of time, usually seconds. This number then has to be entered as a part of the authentication process. Following MFA, I looked at how federation can be used as a single sign-on approach. Identity Federation allows users from identity providers external to AWS to access AWS resources securely without having to supply AWS user credentials from a valid IAM user account. As a part of the configuration process to implement federated authentication, a trust relationship between the identity provider and your AWS account must be established. AWS supports two types of identity providers, OpenID Connect, OIDC, and SAML2. OIDC Federation allows authentication between AWS resources and any public OpenID Connect provider, such as Facebook, Google, or Amazon. SAML2 based federations can allow your existing Active Directory users to authenticate to your AWS resources, allowing for a single sign-on approach. SAML stands for Security Assertion Markup Language. Finally, I quickly covered some of the other features of AWS, which explain how to create a password policy for users within IAM and how this could be configured to reflect your own internal security standards. I then gave a high-level overview of how KMS customer master keys can be created from within the IAM console. Thank you for taking the time to view this course, and if you have any feedback, positive or negative, I would very much appreciate your comments. That now brings us to the end of this course. I wish you continued success with any future development and learning of cloud computing here at Cloud Academy. Thank you.